let's do some curve sketching problems. So curve sketching, they either give you the curve and you have to find information, or they give you information and you have to find the curve, or they give you one curve and you have to find information so that you can draw another curve. They could give you f, f prime, or f double prime. So there's lots of options for what the problem could offer. What the problem offers tells you what row you have to look at. So think about if it's f of x, the y values are the values that your function actually gives you. If they give you the f prime of x graph, they're giving you the graph of all of the slopes. So every single y value is a slope. If they give you the f double prime graph, they are giving you the slope of the graph. So they're giving you the change in the slope. So how fast is slope changing? Is slope increasing? Is slope decreasing? That kind of stuff. All right. So we are given the graph of f of x. Whenever I get a graph, I write whatever that function is on there, so I look back and see it pretty often. It's just a really big suggestion that's going to help you out as you're doing this stuff over here. So you know that every single y value on here is the y value for the actual problem. Okay, so we've got the graph of f of x, so we want to know what are the critical points and all that information. I'm going to refer us back to this paper, and I'll just scoot it so that that's the only one we can see is the f of x. All right, first thing is critical points. Where does f have a critical point? So we're going to look for relative maxes and mins, horizontal tangents, vertical tangents, corners, and cusps. Starting from the left side. Okay, don't just go willy-nilly. Start from the left and move your way through. Our very first critical point is going to be -4 at x equals -4. I will put x equals -4. The next time we get a critical number, that's going to happen at this spot right here. I'm going to go ahead and mark these as I go. Here, that has an x value of 0. Continuing here. That has a horizontal tangent, even though it's not a minimum or a maximum, it's a horizontal tangent, so that's x equals 2. Continuing, x equals 4 is going to be the last one. You can write them all as separate x equals, or you can write them in a list, it doesn't matter. Going from least to greatest is the best option. All right, increasing and decreasing. I'm going to write this out how I do it when I do Algebra 1 classes. I always start again on the left and move my way to the right. Every time you get to a critical point, there's a possible change in increasing or decreasing, because those are where your mins and maxes could potentially be. So start on the left. From -infinity to -4, right? X equals -infinity to -4. Our graph is moving down, so we are decreasing. -infinity to -4. Then from 4 to 1, we are increasing again. 4 to 0. 4 to 0, because it's the x value, not the y value that we care about. Then from x equals 0 all the way to x equals 4, we are decreasing. 0 to 4, so that's negative. 0 to 4. And then from 4 to infinity, we are increasing again. There it is. Next up is relative maxes and mins. There are 4 possibilities, -4, 0, 2, and 4. It doesn't say what are the x values, or at what x is there a relative max or min. It says what are the relative maxes and mins. So we're looking for the x value and the y value. The y value is the max or the min. The x value just tells you where that happens. We do have a minimum here. Again, if I start from the left, there's a minimum at x equals -4. A minimum at -4, -4. Relative maximum is the next guy, 0, 1. And And then our next relative min is at 4, -3. And that's it. Our 2 was not a min or a max because we are decreasing and still decreasing. We don't switch from decreasing to increasing. That would be a minimum, or switch from increasing to decreasing would be a maximum. All right. Points of inflection, that's where we switch concavity. So think about a bowl facing up and a bowl facing down. When do we switch between the two? And we're going to have to kind of estimate here a little bit. Points of inflection, we really only care about the x values on those. So starting on the left, this is concave up, 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 up. And it's still like facing up, but starting right about there, it looks like we switch from concave up, where we could be like holding water in that, to concave down, where the water would be below the bowl, which is not a good thing. It does not have to happen at what we call zeros, right, where your graph crosses the x-axis. So this one particular graph is maybe slightly misleading there. The point of inflection then is at -1, so x equals -1. We are concave down until we get to right about here, right? The bowl is facing down, and then we get kind of this little piece of a bowl. So it's really only the left half of a bowl, but it is still concave up. Because if you completed this, like mirrored it to the other side, it would be a bowl facing upward. So from 1 to 2, we have a little bit of concave up. So that point of inflection is x equals +2. Then I forgot to write down the 1. We talked about it. 1, 2, and then it looks like we switch again right here. So again, this does not have to happen. The points of inflection do not have to happen on the x-axis, and usually they're not. X equals 3. That last one. All right, concave up and concave down. Okay, if you can fill the bowl, it's concave up. So that would be -∞ to -1. Your concave up and concave down are going to switch at these numbers. If they don't, you have an issue. -1 to 1 is concave down. -1 to 1. Concave up again from 1 to 2. Concave down again from 2 to 3. And concave up again from 3 to infinity. Okay. Next, we're going to look at a graph of the derivative. So this is a graph of g prime of x. Notice that the first one was f of x. The second one is g prime of x. I believe this worksheet switched letters, so they didn't so they don't accidentally imply that this graph is the derivative of this one. So they switched letters. So this guy is g prime of x. So all y values are slopes of g of x. So if the y values are positive, the slope of g of x is a positive number. If the y values are negative, the slopes of g of x are negative numbers. If we get zeros, that means the slopes of g of x would have been 0. All right, critical points. Okay, we're looking at the middle one, the middle row, f prime of x. That's the one we're looking at. Okay, critical points happen when the graph crosses the x-axis or just touches the x-axis. I'm going to say touches, crosses. Okay, or when the graph is undefined. This graph is defined everywhere. Defined means that there is a point. There's no like hole or an asymptote, something like that. All right, our graph touches the x-axis here at x equals -4. And again here at about x equals, I don't know, I'm just going to go with 2.5. I know it's not in the middle, but we're going to call that easy. All right, increasing. Where is the graph of g of x increasing and decreasing? Okay, not where is this function increasing and decreasing. Where is g of x increasing and decreasing? Okay. So a function is increasing when its slopes are positive. The y values here are the slopes of g of x. So where is g prime of x? A positive number. G of prime of x is a positive number from negative infinity to negative 4. We stop being positive when we equal 0. So where is g prime greater than 0 is what we're looking for here. Decreasing would be where is g prime less than 0. First one is where is g prime equal 0. All right, so increasing, negative infinity to negative 4. Then again from negative 4 until 2.5. And then we are below the x-axis, meaning that g prime is negative, g prime is the slope, so slopes of g would be negative, meaning g is decreasing, okay, from like 2.5 to infinity. Next, where does g have a relative maximum? Okay, that is this column. G has a relative maximum when the graph of g prime changes from positive to negative. Yep, positive to negative. So you have positive slopes that change to negative slopes of g. So that means that f prime or g prime itself is going to change from positive to negative. That only happens here. Okay, so that means that g prime would have positive, or g has positive slopes and then negative slopes, which means that g would look something like positive, negative. Would have a maximum there. So there's a relative max at x equals 2.5. We cannot tell from this graph what the y value of that maximum was. This is the best we can do, is say what the x value is. Okay, next is a relative minimum. Does our graph ever switch from negative to positive? No. So there are no relative maxes. I'm going to put the word none there. Points of inflection are next. Points of inflection happen, the last one, at the top of a hill or the bottom of a valley of this. Again, we're only going to use x values. So at x equals negative 4, x equals 0, and x equals 5. We are concave up and down between them. Concave up, f prime of x has to be increasing for the graph of f to be concave up. I guess this is g. So if g prime is increasing, then g would be concave up. And that's because concave up means that slopes are increasing. This is a graph of the slopes. So where are the slopes? Increasing. There it is. Starting on the left, I'm going to put g prime increasing and g prime decreasing. And then we can do exactly what we did on the previous problem for increasing and decreasing. So concave down from negative infinity to negative 4. Then we are concave up because, so g would be concave up because g prime is increasing from negative 4 to 0. Then we are concave down because g prime is decreasing from 0 to 5. And then g is concave up because g prime is increasing from 5 to infinity. Last one is second derivative. The second derivative, which is h double prime, is given for h of x, identify points of inflection, and where the graph is concave up or concave down. So where is h? Concave up and concave down, and where does it have points of inflection? Points of inflection happen where the graph crosses the graph of g prime, or letters, h double prime crosses the x-axis, because h double prime has to switch signs. So it either has to switch from positive to negative or switch from negative to positive. Switch signs. I'm going to put cross x-axis. Cross x-axis. That happens at one spot, which is at about 2.5. Okay, concave up is when h double prime is positive. Concave down is where h double prime is negative. Our graph is therefore concave up between negative infinity and -4, and then again from -4 to 2.5, and then concave down from 2.5 to infinity. You're neither concave up nor concave down when h double prime equals 0. So we just kind of skipped that part.